Hello? Can you hear me, Thomas?
I can hears you.
Oh, perfect. Excellent. Let's let the room pile. Everyone's coming in. Jacob, Hannenheim, Brian, all the good people coming in. This is what I'm talking about.
Mm-hmm.
Okay, let me start recording on OBS. Okay, OBS is recording. I have my noise gate open and active. Okay. You gonna jump on camera, Thomas, or you think you're gonna
Yeah.
stay? Okay, perfect. Hey, the beast, the legend, the myth. In his full glory.
I present unto thee greatness. Feast the eyes. Unto thee greatness. Feast the eyes.
For those who aren't aware, but I'm sure they are, Thomas is one of my bestest of pals on Pangburn. He is a brilliant mind who is able to dissect ideas down to their most basic fundamental level. And he always has great questions. He's just a great personality. He's been interviewing people on this platform for what it's been almost half a year now straight, probably like 2-3 times a week
8 months.
sometimes. 8 months. So
Yeah.
he's a legend in his own right and deserves his own like accolades. Like if we had
Same
like
things
belts,
that Don Don is saying about me, right back at him.
that's because he's a nice guy. That's that's the only reason.
But please, yes, do come to my show. You will have a
You
good
should.
time.
Yeah, you will. Of course you will. Oh, we already got 15 human beings. Oh, Barry's here. Hello, Barry.
Oh, is Jason here? Jason, you down there? Spitfire, is he down there? Can you see him? Damn, I'd like him to be on this one. Oh well, I'll text him.
Barry Smith. He's actually going to be one of our guests. If
Excellent.
you can, let me invite you to speak.
Yeah. That invite to speak will be at the top of the screen, Barry.
1 second. Invite to speak.
Mm-hmm.
There we go. Oh, you're in. Amazing. And you can click unmute on the bottom and turn the camera on, and that'd be amazing.
2 little buttons on the bottom center of the screen there. The left one is the audio, the right one is the video. We're still working all the kinks out of this, people. Bear with us.
There we go.
There you are. How are you?
I'm fine. I don't see myself. Is that a problem?
You don't? Well, we see you.
We see you. The call-in sees you. That's weird.
No, sometimes it's as simple as exiting the room and coming back in. Maybe that would work,
Right.
but we definitely see you.
You mean exit the video?
Yeah, maybe.
Well,
maybe turn off the video, turn it back on.
So yeah, I was going to explain to him.
No, that didn't work.
It didn't work.
Oh, now I can see myself.
Oh, there you go. Excellent.
Good.
So just as an explanation, Bear, this is still in beta, so there may be some little glitches here and there, but for most of them, it works pretty well. I only see you now, Don. Now I see him again.
Now I see. Yeah.
It's counterintuitive the way it works, but anyway, now that I know how it works, it will become more counterintuitive the way it works. But anyway, now that I know how it works, it will become more intuitive.
Yes,
that's all right.
Now, Jobst is joining. Unfortunately, Jobst is a very busy venture capitalist consultant type, so he's traveling around Germany more or less all the time. He said he would call in a bit early in order to ask you whether he has your permission to be on video only for the first half an hour or so.
Of course.
And then he would do it by telephone while he's driving.
We would love to hear from him, even if he's only on audio. You know, that's
exactly.
Okay. Well, so.
I mean, I'm down to start
okay,
early
he's down there.
Right.
He's
he
down
is?
there.
Okay.
Yeah.
Do you want to invite him? Let me make you moderator, Thomas, and then you want to invite him
All
up to speak.
right. At the top center of your screen, Jobst is the invite to speak. There we go. Catch it on quick. I love it. And in the bottom center of the screen, you will see the two icons, the video and the voice icon.
Oh, amazing.
So he's quicker than me, you see.
Hello, can you hear me?
Yes,
Yes,
we
we
can.
can.
Excellent. I may have to switch off the camera off from time to time because due to a family emergency, I'm not stationary. I'm very sorry for this. But I think
No,
it will work out.
it's okay. I hope
That's all right.
Yeah, I hope everything's all right.
Yeah, it's a family matter. But I need to go there. My wife is driving, but I'm sorry. But I think it will work out well nevertheless.
Oh, this is a very informal thing, so don't worry.
Yeah,
Good.
we're here to have a good conversation and talk about obviously your ideas, your passions, yourselves as individuals, and I mean that's what I love to do. So,
Great.
Me as well.
Sounds great.
So we've lost your image, Jobst.
Yeah, I switched it off. I'm sorry.
Oh, I see.
No, that's okay. If you stay off, that's completely fine. We can hear you perfectly.
yes,
Right.
we can.
Yes, we can hear you perfectly. So go ahead, Don. It's all you, my brother.
So, we're gonna have today a conversation with Barry Smith and Jobst. I can't pronounce your last name, but I will attempt to. How do I pronounce your last name?
Jobst.
I think we may have lost him.
Well, he's on the road.
Landgrebe.
Landgrebe.
Okay.
Ah.
Okay. So tell me a little. Tell everyone a little bit about yourselves. Like what got you into your work? How'd you guys end up even working together on this project? I'm very interested about that.
Shall I start, Jobst? I'll start anyway. So
Yeah.
I'm a philosopher by training. I've been working in philosophy now for almost 50 years. And at the beginning of my philosophical career, I was working on what you might think of as the history of ontology. And ontology is the science which tries to discover the ways of categorizing what there is in the universe. And so I worked quite a lot on the history of ontology and developed a certain area of specialization in the history of ontology in the Austrian and German lineage of philosophy. And I worked on writing papers and articles. I wrote a book on Austrian philosophy, which connected Austrian philosophy also to Austrian economics. And then I noticed that some of my writings were being cited by computer scientists, particularly in Italy. So there were a group of people who had created an organization which was devoted to ontology in biomedical engineering. So they were engineers working for the government research agency in northern Italy, and they were citing papers by me about ontology. And so I was puzzled because I thought I was doing the history of philosophy, and now there were computer scientists who were making use of my ideas. And so I looked more carefully into what they were doing and realized that there was indeed a way in which the ontological ideas in philosophy were already influencing computer scientists. In fact, that the word ontology had been used by computer scientists already in the 1970s. And this was in connection with work on robotics in Stanford. So the idea of the Stanford AI ontologists, and this was in the era of logic AI, good old-fashioned logic AI.
Mm-hmm, right.
They thought that the way to build a robot that could navigate through the human world and help human beings, for instance, help a human being buy salad in a salad bar, was to create what they called an ontology of the common sense world, which would include an ontology of tomatoes and lettuce and counter and table and customer and dollar and so on, all of the things that you need to know about in your common sense life, create a logical axiomatization of all of these terms, feed that logical axiomatization into a robot, and then the robot would have common sense. It didn't work, but it inspired a whole series of experiments in building ontologies, which were first order logic axiomatizations of, for instance, common sense expressions. And this led to a sequence which went through DARPA, and then from DARPA it went into something called the semantic web, which was Tim Berners-Lee, and OWL, which is the web ontology language, which is the language used primarily by people working in ontology today. Ontology today is still, it's a much more lively area than it was in the 1970s. And an example of an ontology app today is the Siri app in your iPhone, which was built by Tom Gruber, who was actually one of the pioneers of AI ontology in Stanford in the 1980s, I believe. So Tom Gruber has been, in a way, the leader in all of these efforts to do ontology across different disciplines. And what Tom Gruber was especially famous for was the idea that we need knowledge exchange or knowledge interchange formats, which would enable one group's ontologies to be understandable by another group who had used a different format. So we need interchange formats. And the interchange formats were, in fact, the first leg in the direction of what we have today, which is OWL ontologies. And then ontologies still using first-order logic, which are a bit more complicated and which don't work so well in computers, but which, in fact, are more representative of what their target domain is. Now, this is a long story. So I was working on ontology in England and in Germany. I had contacts in Germany, and I was working with my contacts in Germany on some general ontological questions, but they were actually connected with the medical school. And they nominated me for a prize. It was a reverse brain drain prize, which would convince Westerners like me from the wild west of America, Buffalo actually, to move to Germany and found a research institute. So they gave me money. I had 4 million Deutschmarks at the time to found a research institute in Germany. And I chose the topic of ontology of medicine.
Ontology so that would be like the categorization of medicine, right?
Yeah.
Like the concept.
Yeah.
Okay.
Yeah. And this was the first institute in the world devoted to the ontology of medicine. And I had 19 people working for me. We published a lot. We basically created a new discipline of medical ontology. However, I didn't know anything about medicine when I started this. I knew a lot about ontology. Very early on, I was approached by a friend who worked for the NAS. He was an ontology leader in the intelligence community. And he had a girlfriend who was working on something called the gene ontology. And the gene ontology was amazing. So it was an ontology which was the window into the Human Genome Project and the Fly Genome Project and the Mouse Genome Project. All of that data, which was invisible to old-fashioned biologists and old-fashioned clinicians, suddenly became accessible through the gene ontology, which was an ontology of biological phenomena, simply speaking, but which had been used to tag sequence data in the genome repositories. And so it gave you a cross-disciplinary access to huge amounts of data, which you could then use in your experiments or in your clinical research. And it was an immediate success, and it's been growing ever since. And so I said, immediately that I saw this thing, I realized what was in fact false, that I was going to spend my life working with the gene ontology because it was so impressive, so successful, so useful. And but then I started looking at it in more detail, and I realized that it was full of nonsense. So on the one hand, it was really useful and really successful, but on the other hand, the definitions of the terms in the ontology, because an ontology is really a tree of terms,
Okay.
or multiple trees of terms, which are organized hierarchically according to more general than, less general than, part of, adjacent to, influences, and so on. And I realized that the definitions in the gene ontology were really bad, some of them.
What's one example of like a really
So a
bad
really
definition?
bad one would be hemolysis is defined as the causes of hemolysis.
Okay.
That's a bad definition for many
That
reasons.
is-
One reason is it doesn't help you understand the meaning of the word. Another reason is that it would mess with your computers if they tried to use it.
Okay.
And so, and that the gene ontology, like any good ontology, has to be useful both to humans and to computers. So I saw immediately that there was a problem here. I had money. I invited the leadership of the gene ontology to my institute, and I organized a meeting where they could present their ideas. And then I presented a talk. So the gene ontology is called Go.
that is actually what I'm reading right now. Go ahead. No, this is interesting. I had never heard of gene ontology before you'd mentioned it.
Right.
And I just read Go, and I was like, and you said it at the same time. I'm sorry to interrupt, but that was a weird synchronicity.
So then Go, I gave a talk at this meeting called Stop! Exclamation mark. And my talk just consisted of a very funny list of all the nonsense in the definitions of the gene ontology. And all the leadership of the gene ontology was in the room, and they really liked it because for the first time, somebody who knew logic was looking at their work and taking the trouble of finding where it was wrong. And so they put me in charge of the logic of the gene ontology. Now, that meant that within weeks of becoming an expert in medical ontology, without knowing anything about medicine, I was put in charge of the most important computer tool of biomedical research in the world. So I was, in a way, on the bridge of the Human Genome Project, telling them how to build the links, the logical links between biological terms used by humans and sequence data, which is what the gene ontology provided a window to. And so that's probably enough for me for the moment. I will talk, you'll talk about how we met.
Oh, that was awesome.
Yeah. How does this relate to how you guys started working together on this recent project or in general?
We can't hear you, Jobst.
We can't hear you. Maybe you have to unmute or change the microphone. There's a little arrow. Oh, we can
Better
hear
now?
you.
Yeah,
Yes.
better? Very
Yeah.
good.
Yes.
So my life went like this. I studied philosophy first, but then switched to medicine and biochemistry, which I finished in 98 with an MD PhD. Then I went to the Max Planck Institute of Neurogenetics and Psychiatry in Munich as a postdoc and worked on very large data sets, which I created in the laboratory. And they were, at the time, they were regarded as being big data. At the time, they were a matrix of maybe 200 or 300 columns and 30,000 rows, which was a lot of data at the time. And these were biological data, gene expression data. I was one of the pioneers of gene expression profiling in Europe. And so it was invented in the United States, but I was one of the first to use it in Europe. And then I basically realized that to analyze these data, I needed mathematics. So I started to collaborate with mathematicians, and after a couple of weeks, they said to me, you should study mathematics. So I did this in parallel, and I didn't acquire a degree, but the bachelor equivalent I did, but not the diploma. But I then became a biomathematician and worked many years in biomathematics, in research. And at some point, when I was 35, I stopped. I went out of academia, went into business consulting, and that's how I met Barry Smith, because I worked in medical informatics. And can you still hear me?
Yeah, we can
Yes.
hear you.
So it might be good,
That's
Jobst,
okay.
to switch off the image, because then we might have a clearer voice.
Good. So I went into biomathematics. Into medical informatics, and that's where I met Barry Smith, because I was working for an organization called HL7, which very much like the knowledge interchange format that Barry mentioned, that was developed in the 80s to interchange formal ontologies. And I have to highlight that what Barry was describing is all formal ontology. There's also informal ontology, but formal ontology is the ontology that tries to express ontological relationships using logic. And that's what computer scientists need to make the ontology computable, so that the computer can reckon and calculate with the entities the ontology represents. And basically, I was in this HL7 organization, which had and still has the aim to enable exchange of medical data. They call it semantic interoperability, so that you can exchange data, but different organizations can understand what the physicians working in all the different hospitals really meant with the data. And
Okay.
this HL7 organization was very dysfunctional. Can you still hear me?
Yeah, we can
Yes.
hear you. We're listening intently.
It was very dysfunctional. Barry Smith realized this because he was working on medical ontology as well, and he and friends of his created a very funny webpage called the HL7 Watch, which was basically criticizing HL7 and displaying how nonsensical it was what they were doing. And when I was working at HL7, Barry Smith was portrayed to me as being somebody like the Antichrist. So I thought, well, if he's like the Antichrist, he must be clever. So I started to read papers by Barry, and then I found a paper where I was describing BFO version 1, which was basically his now ISO standard attempt to standardize an upper ontology, which is a recipe for creating domain-level ontology. So it's kind of a top level which describes at a very high level of abstraction the types of entities that exist in the world, to put it simply. And I wrote in 2010, I wrote Barry an email about his ontology, where I criticized an aspect of it, quoting Aristotle. Then Barry replied, and that's how we became friends. And we've collaborated a bit in the 2010s. Then we stopped collaborating, and maybe 2016 or 17, I wanted to start writing papers about the problems of artificial intelligence. And I saw these problems very clearly from a mathematical but also linguistic perspective. But I thought that's theory of science, that's philosophy, because I'm not a professional philosopher, but rather a mathematician and biologist. I wanted to work with Barry to write these papers properly. And so that's how we started to work together again. We'd never been totally out of touch because we already had a good friendship going, but that was really the true start of the intense scientific collaboration that we have had now since 7 years, and which had first the focus of working on artificial intelligence together, which I guess we will get back to in the conversation. But the other thing that we now do since 2 years also is
Oh,
Maybe he went under a tunnel.
maybe he's under a tunnel somewhere.
Yeah. That's
Let's give
okay.
him-
We'll wait. Let's give him
Give
a
him another
moment.
10
I'll fill
seconds
in
or
some
so.
of the gaps. HL7 Watch is a blog.
Okay.
I stopped populating the blog a few years ago because we did it. Well, I was principally involved. We won the HL7, which had hitherto been a federally mandated exchange language for medical data. In 66 countries, it was mandated. It was replaced by something else, which is still run by the HL7 organization, but which is logically much more coherent. But HL7 was full of ontological nonsense. So an example would be that a person is identified as a social security number.
Okay.
There are
Okay.
two ways of dying in HL7. One way is the normal biological way, and the other way is if your data is deleted from the database. So
Interesting.
it was full of nonsense. And
I'm interested. How did you change that? What's the
oh,
categorization
just by
change?
the humiliation. So I just, on my blog, I would just repeat things that they said. And
Oh, okay. You just
and the
humiliated them. I
choice,
love
things that
that.
I
That's great.
chose because they were obvious nonsense. And the more of that you present to people, the more people start whispering that, oh, there's something going on here. Barry Smith seems to have found a way of opening the door into the iffy parts of HL7. And I was quite the hero. No one else dared to do this because HL7 knowledge was pretty much a requirement for getting a job working in hospital data tech administration. And so I was the little boy who said that the emperor has no clothes. I'll give you another example. The Boolean. Well, we all know what Boolean means.
Yes.
Like the
And
soup bouillon? Or
in
No.
HL7, Boolean means true or false or one of 14 flavors of null. And the flavors of null include coda could not be bothered to check.
interesting.
And now they also have another term, which is Boolean non-null, which means true or false. So the words in HL7, they look like ordinary words, but very often they have very special HL7 meanings. And some of these meanings are quite confusing, and so they fix them. They give words new definitions because the original definition is confusing. But they don't delete, they didn't delete the original definition.
I see.
And so gradually it became more and more spaghetti-like. Now, if I'm being cruel, I will say that HL7 is like this because that means it breaks often. And then I point out that the people who own HL7 are the medical IT consultants who earn money when HL7-based systems break. And so it was, I don't want to be cruel. Although I did hear at one point that there was a rumor that HL7 had taken out a contract on my life. And my wife was very worried at the time. But,
I'm sorry.
Give me 1 second. I got to fix my camera issue right now.
okay.
That's all right. May I ask a quick question?
I'm back. There we go.
Oh, there you go.
I literally kicked the cable underneath my desk. I got to make sure not to do that. Sorry about that.
That's okay.
So, Jobst, if you can hear us, feel free to interrupt.
Yes, please do. I'm just sitting here absorbing this information. I don't know a lot about. Yeah.
Yeah, I don't know a lot about.
I continued with the HL7 Watch blog, but that was really on the side. My main work was building biomedical ontologies and showing how these ontologies could be useful and training people in using biomedical ontologies.
So how does this? How does this connect with your current book that you both work together, which is "Machines Won't Rule the World"? Right.
Yeah. So this is the part where Jobst comes in, but I'll tell the story from my own point of view.
May I ask one quick question? Just one. I'm sorry.
That's all right.
So biomedical. What did you say? Biomedical what?
Ontologies.
Ontologies. Is that similar to bioinformatics?
Yes, so this is one of the basic technologies of biomedical informatics.
Okay.
And I am, in fact, I started my career as a professor of philosophy. I'm a professor by affiliation in the Department of Biomedical Informatics here in Buffalo. And I'm also a fellow of the American College of Medical Informatics.
Okay. I learned that from Dr. Christopher Mason. I don't know if you know who he is, but
I don't know.
Yeah, I learned that from him. Anyway, thank you for answering that question. I was just making sure a lot of this domain, and I'm sure our audience feels the same way, but domain level ontology is gene ontology a form of domain level ontology?
Gene ontology is the world's most successful domain ontology.
Okay, gene ontology is the most successful.
Every single large-scale genome-based investigation uses the gene ontology as a matter of course.
And for anyone who's watching, do you have a quick way or a small way, a heuristic to help explain people what ontology is? Because I studied at SUNY Stony Brook, So
Yeah.
I know you Buffalo, and I learned what these words mean. And Thomas is a massive philosophy nerd, but there's some people who might. What is a quick heuristic to
Yeah.
explain to people
Good.
what ontology is?
Yeah. So whenever you're working in any domain, whether it's genomics or astronomy or whatever it might be, you have various general nouns like gene or cell or death or diabetes. And these general nouns are associated with data. So you have a certain number of diabetic patients in this city within these years and so forth. So have lots of data which also uses these general nouns. Now, the problem is that databases very often don't use the general nouns that people use when they're talking in English. They use special codes because it's easier to fit them on the screen, or because the special codes are part of a much larger coding system which they've been forced to use by their bosses, or for whatever reason. Databases typically don't use general nouns, and if they do use general nouns, they don't use them consistently. Or they may use M to mean male and F to mean female.
Mm-hmm.
Or they may use M to mean male who has a skill in database design, because they're building a database of people who have skills in different parts of IT. And so they use M, but they don't use it in the way that anyone else uses it. Now, the idea behind an ontology is that you always use the general nouns in the same way by having definitions of those general nouns, both in English and in logic. That the OWL is the web ontology language, and it's the de facto standard language for writing definitions in ontologies.
Okay.
And now you have 100 databases about diabetes, and you take all the column headers in these databases and you tag them with an ontology, the corresponding ontology noun, and then you use the computational powers of the ontology to find data in the database, to check hypotheses about phenomena which the data are about in the databases, and so on. So the ontologies become a kind of window into data.
I mean, this is a really interesting intersection between philosophy and like hard science, which I think a lot of people sometimes miss that. I know Thomas and I have engaged in many conversations where people seem to really dismiss philosophy's validity in its application in hard sciences. And I think this discussion specifically really brings that together, especially the background of how you and Jobst even connected really highlights this interplay between philosophy and science.
I'm fascinated about I'm so sorry to interrupt.
No, go ahead.
I was just going to say, I'm this is fascinating to me, and I'm loving it. I have a computer science degree, but I've never studied domain level ontology in any depth, and I've never understood like ontology when it comes to computer programming and like code compilers and stuff. I know what ontology means. I think I know what ontology means in the philosophical sense. Would you clear this up for me? Would a reductionist ontology in science be like the standard particle physics model?
Right, exactly.
Okay, cool. Just making sure I understood that. See, the ontology you were talking about computational ontology, I guess, and I guess I got lost in a little bit of that, and I'm just trying to help our viewers and me kind of get to a point to where we can understand it a little bit better, but hopefully I didn't get us too far off track.
So by now there are ontologies for pretty much every domain, including ontologies of computing and ontologies of the parts of computers, or ontology of orbits, ontology of satellites, and so on. So there are many ontologies. And the quality of the ontologies at the beginning was very low, but gradually the quality of ontologies is getting better. And part of the reason why the quality was so low is because everybody wanted to have their own ontology. And so you had a kind of explosion of ontologies in specific domains. And people then would say, oh, ontologies, you never know which one is right, which one is wrong. They change all the time. And so ontology, it has a kind of winter, spring phenomenon that you start off. People discover, as in the case of the gene ontology, that ontologies are useful. So everybody wants to have an ontology. And then bad ontologies start swimming around with the good ontologies. And then people then the reputation of ontology collapses, and then people start again building ontologies, and the reputation goes up again, and then becomes attractive, too attractive, and so it attracts not very careful workers and so forth. And so Jobst is
I'm
back
sorry.
here.
Now I've solved the problem. My
Good.
problem was that I wasn't able to connect via the computer, but it works via the mobile phone.
Okay.
Okay, excellent, excellent.
And we can even see your face, although it's jumping
So
up and
should
down a
I?
little bit.
I mean, Barry, I saw that you are explaining computational ontology right now.
Yeah. I was
Yes.
talking about the ontology hype cycle, which is a little bit like the AI hype cycle.
Yeah.
And now let me see if I can bring it back to where we were with Jobst. So I'll just say that during all of this time, and now my work with the biology ontology community had become well known in other areas, and so I was invited by the DoD to help them in ontology building, and now I'm working with a number of other agencies and in industry, in defense, in intelligence, in construction,
I see.
and in homeland security and so forth. So I am partly
I think,
responsible for the fact that there are so many ontologies around.
yeah, I think the key reason. Can you hear me all right now?
Yeah.
Yes,
Yeah.
we can.
The key reason why Barry is successful is the following. There is very little outside. There are some linguists who have a good understanding of ontology, but otherwise outside philosophy, there are not many people. But to organize knowledge properly, to use it technically within computers, you need ontologies. And that there was when computers got used more and more, there was a big gap. And basically, Barry came at the right time to fill this gap, and that's why now he's so successful in so many areas, because everybody needs formally structured representation of knowledge to enable computation with knowledge and to enable human users to use the knowledge, but also to enable computation. And I think that's the reason why it's so successful. Just as a comment.
Yeah.
Okay, so let's get into AI, right? So what is it that you guys mean when you say machines or AI won't rule the world? Like, what do you mean by that statement?
Jobst?
So we hear a lot of, yes, can you hear me?
Yes.
Hello?
Yeah.
Yes.
Can you hear
Can
me?
we?
Yes, we can.
We can hear you. Yeah.
us.
Yes. Okay, so can you hear me now?
Yeah.
Yes, we can.
Okay, I'm sorry. So we hear by Nick Bostrom or Elon Musk and many others that AI will become more intelligent than human beings, that it will develop its own wills, and then that we will have, as Elon Musk has, AI overlords, which will rule the world.
Mm-hmm.
And we believe that this is wrong, and that AI can never achieve this. Maybe Barry can explain our main argument a bit.
Okay.
Yeah. So the AI works really well in some areas, and basically you can characterize these areas in first approximation as being areas where we're dealing with simple systems, or what we call logic systems. And these systems are such that we can describe them mathematically and predict their behavior. So all gadgets, all artifacts, machines, laptops, phones are simple systems. Their behavior is predictable. And that's because we understand them mathematically. And we can only predict the behavior of a system if we can understand it mathematically. So that's a basic thesis of the book. And it's accepted by the mathematicians who write on systems theory. Then there are complex systems. Every organism is a complex system. The weather is a complex system. The seismic properties of the planet form a complex system.
Yeah.
The solar system, treated just gravitationally, is a simple system because we can predict its behavior with very high accuracy, mathematically. So we have two kinds of systems: simple systems, complex systems. Now, AI works really well when we have simple systems. And an example would be the game of chess, the game of Go, or let me think of it. Well, practically
These are
any
closed systems. That's why,
closed
uh,
systems.
yes, they are
Yeah.
closed
Okay.
and
Versus
simple
open
systems.
systems. Okay.
Yes, exactly.
And these are systems where we can write down rules which will enable a reward to be assigned, as in the case of chess or Go. And if you can assign if you can assign rewards, then you can use those rewards to train your AI to do quite impressive things like beat human beings in the game of Go.
Mm-hmm.
But you're still working within a closed world. You're still working within a simple
These are all like weak AI that are designed for singular functions, right? These
Yeah,
aren't actual
exactly.
artificial general intelligences that can learn
Exactly.
and solve
Yeah,
problems and put in
yeah,
a new environment, that
yeah.
kind of thing. Yeah.
And now the artificial general intelligence has the goal of creating an AI which would be comparable in its complexity to human intelligence. Now, nobody knows how to predict the behavior of a human being.
Mm-hmm.
And nobody knows very much about the mathematics of the human brain. If you look at a
True.
textbook of neuroscience, even a very, very big, thorough textbook, you'll find hardly any mathematical equations.
That's correct. Yeah,
But
that's
all
very
kinds of.
correct.
And so our first hypothesis is that we will never be able to have an AI which can simulate the powers of the human brain, because we will never have a mathematical model of the human brain which is accurate at the level of general intelligence. We may have a mathematical model which can predict sleep behavior, for instance, to a degree, but we're not
Okay.
going to
Well,
be able to predict conversational behavior or thought behavior or life planning behavior, because
Mm-hmm.
they're all as complicated as the weather, or perhaps even
Even
more
more.
complex.
So
Yeah.
And
the main argument against our thesis is that we can train by recording human behavior, huge amounts of it. We could train algorithms to emulate human behavior by recording huge amounts of it. And our argument against this is the argument of non-ergodicity of complex systems. And because my connection is so bad, Barry, maybe you can explain what non-ergodicity means and why this prevents modeling with AI.
so
I love this tag team.
to put it simply, there are various features of complex systems which are there are various features of simple systems which make it possible for us to write AI systems which can predict the behaviors of simple systems, because they constrain the mathematical complexity of the simple systems. And one example of these 7 features, which we document in the book, is ergodicity. And now I'm not as trained in data science or in mathematics as Jobst is, but basically speaking, if you have an ergodic system, then you have something like a bell jar with molecules of gas in the system. And the likelihood of a molecule of being any given place at any given time is the same.
In a closed system.
Yeah, it's a closed system, but with uniform behavior. Now, every complex system is non-ergodic, which means
Because it's
that,
an open system. You can't predict that. Okay.
Yeah, and it will also have other properties, such as, for instance, there's no tendency to equilibrium. If you have a simple
True.
system, you will have a tendency to equilibrium.
Correct.
With a complex system, there is no such tendency. So your life as a human being is one damn key.
Go
The
ahead,
key
Jobs.
about non-ergodicity is that non-ergodicity creates different distributions all the time. So no distribution at any point in time looks like another distribution. So you can
Good.
sample forever, but you never find a representative distribution. So if you now train on these distributions from which you had sampled, you train something, but it's adequate only to the past and not to the future, because the future will always look different. And that's the key. That's why
Okay.
ChatGPT is ultimately so repetitive, and why it can only repeat what it has found in the internet of the past, because the internet of the future will never look like the internet of the past due to
So
the
it
non-ergodic behavior of humans.
Yeah,
so
I
it
agree
lacks
with
the
that.
ability of like complex creative predictions. Is that am I
Well,
understanding that right?
So
can it
Even
could
a,
it
even
update
a,
daily?
yeah, even a wave. If you look at the wave, at the molecular level. No wave is molecularly like the other. So if you take all the microstates of a wave, so momentum and location of the particles of the wave, they will never be the same in any two waves, since we have the sea forming waves since billions of years on the Earth. And so this is not a creative system. But it's still complex and non-ergodic, and that's even more true for living organisms. And so
Okay.
if you update ChatGPT daily, you will still not be able to predict what humans come up with, and they come up with new combinations of symbols all the time. And
No, that's true. Yeah.
that's the point.
No, that's
So
very true.
one thing that I'm hearing, guys, is I totally get what you're saying, is that AI in its current formulation, because it deals in closed systems and we're an open system, it's not going to be able to do this future predictive and outwit humanity in a sense. But what do you think about the idea that when they say AI will rule the world or machines will rule the world, we're really, or conceptualize that as not that it's going to outsmart a person, but rather run our day-to-day life, where we can become dependent on it in the same way they were dependent on smartphones, right? Some people make the argument that we are being ruled by smartphones, right? We need a smartphone for everyday life. It's become like how hammer has become necessary for building. Without that, there's no homes. Hammers are ruling us in a sense. That concept, is that something that you think about? Is that something that the book deals with? This
Yes.
idea
So
of becoming so dependent on AI that it becomes intrinsic in everyday life and everyday need.
let me take part of what you just said and run with it. So the idea that X rules Y means that X itself has a will. It wants something.
Okay.
Now, an AI system like a hammer doesn't have a will, and it can never have a will, just as it can never have consciousness. It can never have understanding. But this will thing, it's interesting. I take it you're both familiar with Nick Bostrom's book about superintelligence.
I've
I'm
heard
not.
of it.
Okay,
I'm
so
not.
he talks there about the will, but he talks sort of apologetically, because he says that we don't seem to have any coherent way of describing what the will of a computer might be. That's because computers are not the kinds of entities which are capable of having a will. And that's one of the beautiful things about human beings. We can have conversations which make sense to the conversation parties and which go on, like this one, for instance, for a long, long time, because each of the parties to the conversation wants to achieve something. And that's why, after 50 years of attempting to create effective chatbots to be used by banks, for instance, for customer service calls, why they still don't have a good chatbot. Because to be able to engage coherently in a conversation depends upon having a will, having an intent. My intent is to convince you of the truth of certain arguments. Your intent is to get some kind of interesting content out of me. Jobst's intent is to get a good
I would
signal.
like to
Our
add.
intents are what keep the conversation going.
So I would like to add the following. So rule means the chronic possibility to realize more goals than the others. So the ruler can realize more goals, which means in the definition of Hobbes that he has power. And chronic power is rule. So established power is rule. And that not only needs a will, it needs a will of a long period of time. So every ruler has a very strong will, which he imposes chronically upon his competitors. And that is rule. And tools can never rule us. Yes, we can be dependent on tools, but that means not they rule us. So yes, I depend on my mobile phone for my daily work, but I'm not ruled by it. Now you could say some people get addicted to alcohol or their mobile phones, but that still doesn't mean they are ruled by it. So this is once more about rule. And because computers will never gain consciousness, and if you want, we can explain you why that is the case a bit later. They cannot never have a will, because consciousness is a prerequisite for a will, actually self-consciousness. Now, as to chatbots, now you could argue that chatbots now work because ChatGPT is a chatbot that works. I would argue that it doesn't work. And why doesn't it work? Because ChatGPT can only be, for mathematical reasons, be trained to give one answer to one question properly. Because you need billions of question-answer events to train it with a gradient descent method that is used in reinforcement learning for the last training step. However, that's the key point. Can you still hear me?
Yeah, we
Yep.
can hear you.
Hello?
Yes, we
Yes,
can
yes,
hear you.
yes, yes, yes.
Hello, hello, hello. Have
Hello?
we lost you?
Yeah, we
Hello?
can hear you. He might not be able
Okay,
to hear us, but we
so,
can definitely
and
hear.
the
Oh,
key point is that thank you, to train, if you wanted to train longer conversations like they occur with a bank employee, then you have a combinatorial explosion of questions and answers for which you cannot train ChatGPT. And therefore, when you conduct such a longer dialogue with ChatGPT, you can make it, for example, praise Adolf Hitler. And you can do that because by doing the longer conversation, you are exploring a phase space of the bot that actually has not been trained and is never trainable for combinatorial reasons.
Hmm.
Hmm.
I think that because I think that we could probably have like trillions of weak AI working together to mimic human consciousness, but I don't know if an AGI is possible.
So the AGI question is on the one hand into equal intelligence.
Yeah.
There is another question whether the AI system could have something like the consciousness or a
Right.
will
Right.
or understanding. So understanding presupposes consciousness.
Well, you said complexes, and I'm sorry, Jobst, to interrupt you there. I loved what you were saying. Um, if so, our brain's a complex system, about 86, 87 billion neurons. So, so many petabytes of information that it can store. But the connections in between neurons are like more than the stars in the Milky Way galaxy, right? So you don't think that a complex system, whether silicate based or whatever it may be, that this AI becomes, you don't think it can emerge something? Anything? I mean, maybe not consciousness, but just becoming so complex with a just an outrageous amount of weak AI that maybe something would emerge from that.
I'll take
Hello?
on that one, I think.
Yeah. Go ahead.
All right, so let's just start with two. We have ChatGPT or Chat 4.0 or 7.0, whatever you like, in computer A, and we have ChatGPT in computer B. And now we get them to chat to each other. Could a will or intelligence or, a will or consciousness arise just through that? I think we'd all agree that it couldn't. But let's think about why not. So the computer on the left, we'll call it A, has been programmed with a certain finite amount of data drawn from the web and using a deterministic, well, actually, it's slightly modified deterministic, but it's an algorithm which yields outputs from inputs. It's not deterministic because they add a little bit of randomness to prevent repetitive answers.
Okay.
And that is a simple system, which means that there is there is a determined range of what the outputs can be for any given inputs. It's basically it's
Mathematically,
a complex polynomial which gives you an output from an input. And the same applies to computer B. Now, computer B is a simple system. If you put two simple systems like that together, where the only will is the will of the designer of the system, and the designer, and maybe there are two designers, two human beings. One human being is telling computer B what to say, and the other is telling computer A what to say. But some human being has to be starting this conversation between A and B.
Mm-hmm.
And so either you depart from the regimen of a simple deterministic system because there is one human being involved, or because there is two human beings involved. But if you leave the two systems all by themselves, they will not interact.
Mm-hmm.
And that's just for two. Now, we could try it for three, we could try it for four. I don't see why anything would change if we move up to ever larger numbers. There's nothing suddenly which is going to happen, because we're dealing with Turing machines, and Turing machines place very, very strict constraints on the kinds of mathematical equations that they can solve. So it's the polynomial functor or operator, which is the ChatGPT in computer A, has billions of parameters. It's a really long operator.
Okay.
But
So
it's calculating very, very simple 0 and 1 based arithmetic at every step, because it's a Turing machine, and that's what Turing machines can do.
Okay. Thank
so
you.
you sold me. You sold me. I understand what you mean by AI won't rule the world. But how would AI play within the way in which, I guess, would be a tool to either subjugate or utilize one class against another class? Or how is this understanding of AI, as you and Jobst are presenting, is how would this play out in like policy decisions for
Yeah,
governments?
good.
Or how
So
would this play out in the way in which, yeah.
Jobst is adding, he wants to be added as a speaker. It
Oh,
seems he's been
can
dropped off.
you do that, Thomas, real quick?
Oh, yes, I'm sorry.
I'm
I
only
didn't know
asking
that he
because
had
I'm
dropped down.
recording the screen and I don't want to
Yeah.
keep scrolling and moving my camera and stuff all over the place.
Well, it says to me that he's still in the speakers. I hate that we're having such technical difficulties, guys. I apologize.
Well, I'll tell him we're working on it if I can find a way to add this to the chat.
I got it. Invite to speak. Yeah, I just did it. Okay.
Okay.
It must be frozen for me.
Yeah. Colin is still in beta, so we might have these technical issues, but usually, as we can see, it usually works all right if you're, stationary. I think the AI hasn't figured out how to navigate the satellite yet.
This is a big test. So let me do a little bit about addressing your rule question. So first of all, every piece of technology can be misused by evil human beings. So from that point of view, the nuclear bomb is an interesting subject matter to think of. So I don't think that AI systems are going to be immune from being misused by evil people. So some people worry about the powers of ChatGPT because they can create deep fake videos. Deep fake videos are really horrible, they think.
Yeah.
But we've had deep fake videos for how many years? Probably for 5 years. And there are no really horrible things happening from deep fake videos yet.
But you can see the way in which I think like the GOP, the Republican Party, just released an entire AI created ad. And many people have, from QAnon to other conspiracy theorists, have used deepfakes and all these other ideas to manipulate the public.
Yes, but they've used lots and lots of different ideas to manipulate the public. True. I don't think the deep fake technology has been a major menace to human life, to the normal running of human life in the last years. It's a nice thing to be scared about, but it hasn't actually created a major menace. Partly because AI very often has the ability to solve problems that it itself is enabled to be caused by human beings. So there are now apps which can detect deep fakes, and those there'll be an arms race between the deep fake producing ChatGPT experts and the deep fake identifier producing technologists on the other side. And that's going to happen to many of the things that people are afraid of in the development of ChatGPT. That there's going to be a development of counter measures to the bad things which people learn to do with ChatGPT, if they learn to do them. That's.
What about things like job displacement?
Okay, so.
That's all right.
So Jobst he says he's really ashamed.
He had a family emergency. He shouldn't be ashamed. The fact he even came on to begin with is just so honorable as it is, and we thank him for even trying to get this to work. So,
okay, so the last question that was just raised before I was pinged.
Yes.
Can you repeat it?
how do you think that AI plays in with job displacement?
Okay, good. So again, no one can know, but in earlier phases of technological advance that we've seen in the last 100, 200 years, the new technology has in general led to new jobs. And there is a phase during which some people lose their jobs. And the explanation. So I'm going to respond to him.
That's totally okay. We're not in any
Yeah,
rush.
that's totally okay. We're not in any rush.
Yeah.
No rush.
So anyway, he's in a storm. That's why.
So not only is he on the road, he's in a storm.
Yeah.
I mean, I'm surprised it lasted as long as it did, honestly.
Yeah. All right. So so that's the idea. The ChatGPT is already leading to new kinds of jobs. So there now are people called prompt engineers whose job is to help people write prompts for ChatGPT. I know at least one company where they've changed their organization entirely, the organization of how they do their work, because they use ChatGPT for nearly everything. But they haven't fired any people. They're just doing work much more
Yeah.
efficiently and effectively, but they're
Yeah,
doing more work
exactly.
as they can
Yeah.
do. So technology is good in general, and it does lead to new jobs, but it may along the way lead to some people losing their jobs. Now,
Yeah.
will all lawyers lose their jobs? Will all doctors lose their jobs?
Not all of them.
No.
ChatGPT can pass medical exams.
Can
So I think
ChatGPT play basketball?
yeah, it's partly that. So there is certainly a degree to which ChatGPT medical diagnoses and medical treatment plans can be significantly better than the average physician. Not better than a good physician, but better than the average physician. But what that means is that every physician has an opportunity of doing better diagnoses and treatment plans by using ChatGPT. But it's still going to be the physician's job to check that the plan is coherent, because, as I think you both well know, ChatGPT tells lies and
Oh,
it
yes.
makes stuff.
Correct.
And
Yep. I've gotten it to tell me lies, actually.
yeah.
I challenged it to tell me a lie, basically, and just kept putting stuff in, and it eventually did.
Yeah.
So,
But of course, it doesn't tell lies deliberately because it doesn't have a will. So.
that's
True.
the weird thing. Yeah, that's
This
so,
whole
go ahead.
when you talk about will, what is your conception of will? Is it like Schopenhauer's conception of will? Like, where are you getting your conception of will from?
Okay, so in the book there is a section on the theory of the will put forward by a philosopher called Max Scheler. He's one of the philosophers I studied in the early part of my career, and the account is it's based upon a rescue scenario where there is a man walking along the side of a river, and he sees a child fall into the river. And there is a question, will he rescue the child? Now, Shayla does this for the rescue scenario, but the same account would work for a chess playing scenario, deciding whether to move your knight or not to move your knight. So it's a perfectly general account. And the idea is that there are certain phases in a rescue scenario. So first of all, there's the perception. Secondly, there is the feeling on the part of the man on the side of the river that the child has fallen in and needs to be rescued. So there is a child needs to be rescued feeling that the man has. And then the third phase would be where his brain starts to work out very quickly how he would execute the rescue. So whether he can run quickly enough, in which direction he could run, whether he can swim in that particular current, and so on. That happens very, very quickly. And then finally, there is a crucial turning point, which is both in his mind, in his consciousness, and in his brain and his body, neurologically, neurophysiologically, where he actually wills that he will rescue the child. And then he starts running. So that the muscular instructions to start running and the decision, the act of will in the brain as a conscious phenomenon are two sides of the same event. There aren't two events here.
So like the relation between
That's the
action
will.
and thought, in a way, is what you consider will.
Yeah, where action and thought come together is will.
And AI doesn't have this.
Of course not. It doesn't
Of
have
course
any
not.
thought.
Yeah, it doesn't have any will in that respect.
Yeah.
But what about like the idea of almost like a systemic or social will, a direction to any type of systems as they operate, whether it be self-fulfilling positive feedback loops? Can a economic or social system within AI have some sort of exponential dependence upon a specific system? Not rule in the way that we spoke about it, but can you see AI becoming so integral in day-to-day life? I know I brought this back again, but I'm thinking in the way in which these concepts, these entities, these tools, kind of like when they become so complex within the system itself almost like has a will above us.
Yeah.
Do you recognize
Right.
that as a possibility or not as a possibility?
Yes, so Jobst and I have talked about this, and he has actually written about it also. So
Okay.
there are various levels of power, and the most crude level of power is the biggest man with the biggest muscles and the biggest stick will rule the other people.
Okay.
That's the very basic kind of power, and then we have more and more sophisticated kinds of power on higher levels, including knowing that person A can call on the police with the big stick to come and get his wishes realized. And now at the very top, we have what Jobst calls the, I've forgotten the exact expression, but it's something like the data setting power. And the data setting power means planning where the road systems will be built and how they will be maintained, or planning how the voting system will work, or planning how the immigration system will work, or planning how the social security system would work. So China has data setting power over very many aspects of Chinese people's lives, which is based on the use of AI. But I don't think that it's the AI which is doing the implementation. It's the will of the Chinese Communist Party and its members who are responsible for deciding the data setting. It's just that the tool for data setting is, in this case, AI. And that's a very important phenomenon, the social credit system.
Yeah.
And I understand that it's breaking down, actually, because China has so many people. And to keep one of these systems running coherently when you have so many people is a big job. And it turned out that it was not working properly because there were so many people and they were much too ambitious. And so it's gradually, as I understand it, being dismantled, which would be good news, of course.
That would be good news.
How have you been using the AI in the past since it started becoming popular? Do you use it in like your day-to-day life? Do you find yourself being drawn to it?
I was drawn to AI primarily because of Jobst. So he called me out of the blue, the first communication for years. And he said, "Barry, I need to come to Buffalo." And a few days later, he caught a plane. He came to Buffalo, and we worked for 4 or 5 days intensely on what we thought would be a paper. And the paper, he had a company, an AI company. The company still exists. He's still working for this company. He's the owner of the company. And he had problems with his customers. So they wanted him to build chatbots, for instance. And he told them, you can't build a chatbot. It's impossible. There is no successful chatbot which can do anything intelligent. And the counterexamples in some countries, it seems that China may be a typical country of this type. Older people like a kind of soothing chat which doesn't contain any kind of intellectual level. It's just, how are you feeling today, and so on. They like that, and so those kinds of chatbots are much used in China. But that's not what Jobst's customers wanted. They wanted a chatbot that would help them with their customers, or chatbots that would enable complicated instructions to be communicated. And Jobst knows that you can't build such chatbots because he knows that there are strict limits to what AI can do. And there is even a section on what we call foundational models, which is what ChatGPT and the other large language models are in the book. It's only 2 pages. We didn't anticipate the fantastic displays of ChatGPT, which would come a few months after the book was published, but we did anticipate the technology. And it still fits into our schema. So since the book, I've been paying more and more attention to AI for obvious reasons, because we both of us been talking to people with an interest, such as we are doing at this moment. And when ChatGPT came out, I was immediately interested in testing it, because I wanted to show that it wasn't the wonder miracle tool that many people think. So I know that it can do fantastic things. And I have friends who, as I think I mentioned a few minutes ago, have used it to transform their company in all kinds of interesting, positive ways. It's a company which does a lot of classification and does a lot of interaction with customers about how they are making decisions about certain things. And ChatGPT seems to be a very useful tool for that kind of work. But my job, as I saw it, was to kick the tires of ChatGPT, to find out how bad it is, how many mistakes it makes. And so,
in the same way that you did the same thing with biomedical ontology.
Exactly. I like kicking the tires of things. So I have a series of videos which are about how ChatGPT fails at certain very obvious jobs. So I'll give you just one example. I asked it to list the 5 most important publications in biomedical ontology of the last 5 years, something like that. And it listed 5 publications, 3 of which were published in something called the Journal of Biomedical Ontology. And I was intrigued, because I know that there is no such thing as the Journal of Biomedical Ontology.
Interesting.
And all the 5 papers didn't exist. And I knew that because they had authors that I knew, and I knew what the authors had published. And so I asked it, who is the editor of the Journal of Biomedical Ontology? And it said, Barry Smith. So, so there have been dozens and dozens of such experiments. So basically, the way ChatGPT is trained, and I know that, sorry, I don't know your names, but the gentleman...
I am Don, and this is Thomas.
Okay, so Thomas, a few minutes ago, suggested that we could update ChatGPT every day. And that's going to be very expensive as things are currently, but it's also going to be problematic because of the use of computer time. But there are other problems with that sort of approach, which we can talk about in a minute if we get to them. So ChatGPT is trained by crawling the net, and there's also some code data which is pulled in, and surely various other things, and maybe not all the net. We don't really know what the training material is, but we know that it's going to be primarily from trawling the net. And the net contains a lot of data about some things, very little to no data about many other things. But then you'll have some areas where it gives bits and pieces of data. And now, if you ask questions about Michael Jackson, or about Obama, or about Clinton or Trump, you'll immediately get correct answers, because there's a huge amount of data
on it. Okay.
People. But if you take a fringe person like Barry Smith, or a fringe occupation like biomedical ontologist, then you generally get poor answers. And now, part of the reason for this, I think, is because of what makes ChatGPT an absolutely fantastic achievement. So I really think it's very, very interesting and a good thing in general, is the reinforcement learning methodology that they used to make it yield answers in the way that it does. Basically, when they built AlphaGo, they used reinforcement learning. So they had a rule system for moves in Go, and they used that rule system, which assigns a reward for different kinds of moves, to play billions of games of Go inside the computer. And then the computer could survey these games statistically and work out which strategies in which context lead to which end results. And then it could maximize those strategies which lead to positive end results in the form of winning the match. And in that way, it could train itself via reinforcement learning. In fact, it gets a reward for telling lies because that's content. It's helpful.
Because it's okay.
Now, the reason why I say this complicated is because of this. And I'm really not an expert. No one is an expert except the people who work for OpenAI. But GPT 4.0 does not contain a reinforcement learning stage in the training of the algorithm. And yet GPT 4.0 still avoids, it doesn't avoid it completely, but it avoids it largely giving I don't know answers.
That's
and so
interesting.
it can't be the reinforcement learning which is explaining why it lies.
Yeah, for $20 extra a month, it can tell you why it lies.
Well, no, I paid the $20.
So I don't. How much more time do you have with us? Because I do want to open it up for a little bit of questions for the. Okay, great. So before we open it, if you have any questions, people should just line up in the callers. But I want to ask you some other questions. Did you think growing up, like, first of all, what got you? Like, when you look back at like your childhood, did you always like kicking tires? Did you always like dissecting and pulling things apart and showing where they're wrong?
So I tend to be a what's the word? Contrarian. So if most of the people around me are saying P, then I like to find ways of saying not P. That's the first thing. But at the same time, I was also
resonate with that.
A very young age interested in making the world perfect. Now, what that means is becoming a mathematician. So if you become a mathematician, then you're living in a perfect world, the world of mathematics. I wanted to make the rest of the world as perfect as mathematics. And that's why I became interested in ontology, because an ontology is a picture of the world, but it's more perfect than the world itself.
Mm-hmm.
And so that's...
Well, with you wanting to make the world perfect, is it? Did you find that you did make it perfect, or like what is the biggest part? Like you didn't expect this in your life.
I didn't really think that making ontologies would make the world perfect, but I thought it would be a bit easier than it actually is. But building ontologies is a really hard business because there are people involved. And people have different ideas about what words mean and how words should be used. And and how they should be organized into trees. And so, although I've worked in ontology now for 30 years and built many ontologies and trained many ontologists, it's still not any easier. It's still a hard battle each time.
I see.
As for kicking the tires, I guess I was, I do have a tendency to kick the tires in the sense that I don't like, pride is not quite the word, misplaced pride. I
Okay.
like pride when it's justified, but
You don't like misplaced arrogance. I mean, I can
yeah,
really
that's right.
resonate with
Arrogance,
that.
I don't like.
I know growing up, I did a lot of martial arts, and like traditional karate didn't really work in many like street
Oh
fights. Like
yeah.
I was really focused on that. How does that? Did you grow up in a religious home? Is that something that you battled against? Like, what is your current position on all
So
of that stuff?
my parents were not religious, but they went to church on Sunday to some degree. I actually joined a church choir when I was quite young, and I left the choir, left the church at the age of 13. But I still have a strong fellow feeling for people who are religious believers. So my wife is a Catholic who is the head of the parish council, and she spends half her time in the church organizing things. So, and I'm very pleased about that. It seems to be a good thing. She is a true believer in every possible sense.
That's excellent.
Did you ever try to kick those tires, and that get you into trouble ever, or no?
No,
No.
I by expressing support for religion in an academic environment like SUNY Buffalo, I am kicking everybody's tires.
I see. The contrarian to the contrarian.
Yeah.
I see. Thomas, you have any other things to ask, or are
No,
there
I
even
mean,
callers?
we do have callers. I was just
Okay,
going to say, I love talking to you, Barry. I think you're a brilliant person. I'm
absolutely.
still, I'm literally right now using ChatGPT to try to formalize my understanding of domain level ontology or domain specific
Oh yeah.
ontology, biomedical ontology, and computational ontology. I think I've got a grasp on it all. Is it all under the moniker or the overarching category of domain specific ontology? Is that what everything else
So
kind of
top
falls
level
under?
ontologies are domain neutral.
Yes.
And I wrote with the help of my colleagues, I wrote the top level ontology called basic formal ontology, which in 2021 was declared conformant to uh, International Standard 21838-1, which I wrote. 21838-1 is the standard for being a top level ontology, and 21838-2 is about basic formal ontology, which is the ontology that I and all my co-workers use, and which is a reverse engineering of the top level of the gene ontology.
Okay.
So it's just the most general terms at the top of the gene ontology, basically.
Okay.
And so now that ontology is used in something like 500 ontology groups as their
Jeez.
top level ontology.
Looks like I have a long road ahead of me.
We all do.
But
I mean, listen.
there is another book which is called Building Ontologies with Basic Formal Ontology, published by MIT some years ago. You could look at that. It's probably available cheaply on the web.
I will. I'll do my due diligence. Thank you, my friend.
So, so let's move on to some callers. Thomas, if you don't mind, just because I'm recording the screen, do you mind bringing the first caller? Thomas?
All right. I got it. I got it. Aaron. Yeah, there you are.
Oh, but real quick, let's just try to keep it to one question, and then we're going to move from one person to another. Let's try not to have a back and forth dialogue too much, and you can always jump right back onto the queue.
let's let. Yeah, I was gonna say let's let Barry get in here.
Good. So,
Real quick, Aaron, can you just mute yourself? Okay, thank you.
so they were good questions. I would say that you would have me worried if you could point to a situation that you're now in where YouTube algorithms are forcing you to watch only certain videos. In other words, they're not leaving you with any choice. But the recommender systems which you are worried about, they do leave you with choice. You can choose other YouTube videos to watch, or you can do something quite different. So you're not ruled by these algorithms. On the contrary, I would say that the algorithms are helping you to lead a better life because they're identifying videos that you otherwise might not find, but which you enjoy.
Mm-hmm.
So in either case, I think that you're in good shape.
Good answer.
Great. Who's our next caller?
Our next caller is Tree, one of my friends, our friends here.
Yes, they
Let's
are.
see what we got. Yes. Hello.
Yes, you are.
So if we're right, if the mathematical basis of our arguments, and we're taking our arguments from perfectly standard mathematical theories of complex systems, then there is no way of landing by accident or landing by something which is similar to an